I'm Dr. Ramesh Babu, Professor at Department of Civil Engineering, NALLA NARASIMHA REDDY Education Society's group of institutions, integrated campus, Hyderabad, structural engineering, reinforcement, cement, concrete. See, in previous videos, I explained how to find the depth of the foundation. In continuation, that we have to see that the uniform settlement. Even in weak cells, you can go for pile foundations. So depend upon the practical conditions, even though we have IS code requirements and Rank's formula, depend upon the height, generally 5 to 10% of the height, we have to consider 1.5 times nearly say 5 times minimum of the depth of the footings. Like that, minimum depth we have to consider in practical by considering practical considerations, because the foundation should take all moments and loads which will transfer to the uh, from the superstructure to substructure. That side should bear that capacity. Types of foundation of different structures. Silo foundation directly on the supporting side. This foundation used when silo side can safely support the foundation loads. What is this meaning? This is hard soil, good soil. That is, in good condition of soils, we'll go for shallow foundation. The depth will be less, and whenever depth is more, we'll go for deep foundation. So when hard soil, that is like muram or rocks, will go for shallow foundation. Yeah, deep foundation, if the soil is weak, will go for deep foundation. Deep foundation may be selected if soil cannot economically support the foundation loads. Deep foundations consist of footings that piers that piles. Pile foundation, that's a separate design and separate subject. Pile foundation also very important. Near sea, in weak soils and coastal area or seashore areas or nearby rivers, will go for pile foundation. Inside the soil also, we go for pile foundation. The footing and the above that piles, we have a combined slab, then we'll start their pile cap, and above that we'll construct the superstructure. So deep foundation generally uneconomical, but wherever this is required, we have to weak sides, we have to go for deep foundations. And the piles are supported by deeper component soil and are supported on bedrock. It is commonly assumed that soil immediately below the pile caps provided no direct support in the pile. See, whenever piles, it should go that dry depth. Yeah, spread foundation. What is this? Generally, it is most commonly used is this spread foundation, that is reasonably bearing capacity of soil. Wall foundation. This is, if you see, this is the wall foundation. If you see this one, if you see this one is wall foundation. You see, if you see this one is wall foundation, right? Okay, spread foundation like this, and wall single wall foundation at combined stuff like this combined stuff. This is combined footing like that weak soil. This is become uneconomical, but whenever soil is medium or not uh, taking loads, when bearing capacity is very low, we'll go for spread footing. That is, this is one type of footing. Okay, design factors. So what are the design factors? Just till now we discussed about the foundations, but whenever we'll see go for design factor, the bearing pressure is assumed to be uniformly distributed. Coarse grain soils, individual coarse grain soil moves outward. Clay soil, shear resistance around the parameter. Say this is the two different types of uh, figures, you see, if you observe, there are two sides. Coarse grained soil, this will move upwards, outwards. Clay soil, shear resistance around the perimeter. So this is, you have to observe carefully. This is a very important. In exam point, you have to write always. You have to mention what is the clay soil figure, what is the uh, yeah, coarse grained soil. So these figures, two figures are very important. This is a, however, we'll assume in designs, whatever may be uniform or this convex or concave type, we'll assume uniform in our designs. Okay, this is very important point as a design factors. Okay, right. Now we'll see some more topics, footings and foundation. What are the other design factor? It is customary to discredit these non-uniformities because of their numerical amount is uncertain and highly variable on types of soils and their influence on bending moment and shearing forces, shearing force and soils and their influence on bending moment and shearing forces in the footing is relatively small. Okay, layout of the structural supports vary widely and soil conditions differ from site to site within a site. As a result, the type of foundation to be selected has to be governed by these factors and optimal cost consideration, basic knowledge of soil mechanics and foundation engineering assumed when design of footings. This is very important. Basic knowledge of soil mechanics are also very important in the depth of foundation engineering and assumed when design footings. Background of knowledge of methodology determining the resistance of the soils is necessary to select the appropriate bearing capacity value for the particular site and particular foundation system under the construction. See, layout of this layout of structural supports vary widely and soil conditions differ from site to site within a site, and as a result the foundation to be selected has to be governed and optimal cost consideration, basic knowledge of soil mechanics and foundation engineering assumed when design footings, background knowledge of the methodology determining the resistance of the soils is necessary to select the appropriate bearing value for the particular site and the particular foundation system under consideration. Okay, see wall footings. Now this is which you are having in syllabus. What is the wall footing, right? See, the simple principle beam action apply on wall footings within minor modification, that is concrete wall, the movement is computerized phase, that is mu equal to 1 by 8 q b minus a square, where b is total the width of your footing minus a is width of the column, q is bearing capacity of your soil, mu is that is the moment, that is mu movement. We have to design for this one. And also vertical shear force is at a distance d from here. If you see this very important point, again I will explain yeah, as many times as in the coming chapters also. And this is very important. Yeah, here this is very important formula, mu equal to q by 8 and b minus a whole square, that is b is total width of the footing and a is width of the your column. See, b is your width of the footing. Now here d is depth, yet d, this vertical shear force, this is you can call as a one way shear at d, this is vertical shear you can call, this is at the d distance. So effective depth from the face d fall face vu shear force is equal to qu into b minus a by 2 minus d. This you must remember this formula, and you can derive this is a like simply supported cantilever beam, simply supported, not simply supported, that is cantilever beam, that is you can design, and this you can calculate the movement and vertical shear. So this is very important point. One is how what is vertical shear is computed at a distance is D is from wall surface D, right? Now the moment is supported midway between middle and face of the wall. So moment is always you have to consider from the base of wall, and this is a simply you can consider is a you can consider this is a like cantilever beam. From this one we derive that moment and vertical shear. So in this way we have to do the problems, and here shear will act at the effective depth from the face of the column and moment from the face of the column, and shear is the distance effective depth from the face of the column. Both are at the face of the column you can calculate bending moment, but one shear is away at the effective depth. This is very important bit question for you, very important topic. Your design of wall footings, how you are going to design, we'll see step by step in the next class. And also if you see d by 2, that is punching shear. What is punching shear? At d by 2 you will have that punching shear that will act on the footing. How will act, I will show you with example, right? See, this is punching shear, so the shear failure may be like this. This punching shear will fail you. There are two types of shear failures in the footings. That is, one is one-way shear, second is two-way shear. In two-way shear, that is at d by 2. That punching shear is at D. These are difference. You must remember these two. These are very, very important and in point of view, and these are very important. So if you see this one, yeah, this is very important, and as I explained in the previous slide, you must remember this moment equation, that is 1 by 8 QU B minus A whole square, that is shear force is equal to Q U and multiplied by B minus A by 2 minus D. And I will end this class, and I will explain one problem in the next class. Thank you. Thank you all.